Today I will talk to you about app optimization with instruments. And in this talk, I will focus very much on instruments as a tool itself and how to use it to track down performance issues or memory issues in a relatively complex real-world application. I will basically not talk about the common solutions to these problems, because there are a lot of good resources out there, including Apple's own WWDC and Tech Talk sessions, which cover all the basics there. So specifically, I will focus on three basic features of instruments. And these are the time profiler, the core animation instrument, and the allocations instrument. And I will start with the core animation instrument because it's somehow the most accessible of those. It doesn't require you to dive into call stacks and stuff like this right away, but it's a much more visual way of tracking down graphics performance issues. So the core animation instrument is all about answering questions like, how is your app's graphics performance? What is the frame rate of your animations? And why is the frame rate like this? So it gives you some insight into the rendering process. How are your layers composed? And so you get some information about why your animations might not perform like you want them to. The core animation instrument is only available on the device. However, a few of these tools I'm going to show you are also available directly in the simulator. So they are built in there. You can use them without instruments. But I will show you this in a second. And the fact that it's only available on the device, of course, also makes sense because graphics performance matters on the device. And testing it on the simulator is a bit pointless if it's about performance. So I will dive right into the first demo. When you want to start using instruments and you're working with Xcode, then you can start instruments with the product menu. There's this profile option. Or you go to this run button and click and hold. There's also profile option. Or if you work with app code, it's the same thing. In the run menu, we have profile. And then hidden in the upper right corner, there's this tiny little instruments button, which you can use. And now I have to quickly check if my network address is still the same. Seems good. So I will try to launch my first demo here on the device and show you how to use the core animation instrument. So I start this from here, and once your project is built and deployed to the device, which I have here, then instruments will come up with a dialog, and it will ask you about the template you want to use. Okay, so far so good. That works. So we will choose the core animation template here. And once I say profile, instrument starts recording right away. And when I switch over to the device, here we are. Perfect. Okay. Here we have a horizontal scroll view, as you can see. And when I scroll this forth and back, it's AirPlay, so you cannot really say how smooth it performs. But I can tell you it's not really smooth. And it's much better to show you this in instruments itself. So I will switch back to instruments and stop it. I have to go back again. Okay. And now you can see here in the core animation track, if I move the timeline head over this region where I scrolled, then you can see that we are reaching barely 20 frames per second. So this is clearly not good. So the first thing you have to do in these cases is you have to answer the question if you are GPU bound or CPU bound. And conveniently, the core animation template places the time profiler in the second track. So what I will do is I will open this inspector pane of the time profiler, and I will switch the display style to CPU usage. And once we did this, and I again move the timeline head over this region, and you see that the CPU load is somewhere between 10 or 15%. So we are clearly not CPU bound in this case. So let's find out what might be the problem here. And for this, I will just start up the app again on the device. The app's already installed on the device. I didn't change anything, so I can just start it right from instrument by hitting record. Then it comes back. Okay, and the first thing I will show you is this option called, I have to zoom in a little bit, called color blended layers. If you flip the switch, then you will see on the device that now instruments tint all the regions of the screen in red where layer blending takes place. And layer blending always happens when your views are not opaque. So if you have transparency, then all the layers need to be blended into each other one by one, and that's a performance hit, of course. So here we see a lot of red, and we see even nested red boxes. So this could be one problem in this case. Another option I want to show you is, let's switch this off, color off-screen rendered yellow. And what this does is, when I switch back to the device, it tints the regions of the screen in yellow where an off-screen rendering path was necessary. And you can see in this example that it's only these tiny little rectangles around the rounded corners of the layers. And the last option I'm going to show you is the one which is called color misaligned images. And this one will color everything in yellow, where the pixels of the image do not match up with the pixels of your screen, so where image scaling is necessary. You might also see magenta coloring here, and magenta coloring means you have subpixel alignment problems. So let me stop this, and I will show you another version of this app. I have this version already installed on the device, and in this case I can use this pop-up menu up here, and I can attach instruments to a running process or to a target, which basically means an app which is installed on the device. So I will choose this one, and I will hit record, and the app starts up, and instrument starts recording. So I have to switch off the color misaligned images. Let me go back to the device. Switch over here. So now in this version of the app, if I do the same thing, if I just use this horizontal scroll view and I start scrolling this left and right just to test what's the frame rate here, and I come back to instruments, then you will see that in this region we are now hitting 60 frames per second as it should be. And now I will use instruments to show you what has changed. So I will start the app again, and I will switch on the option color off-screen rendered yellow. And then you will see, I have to go in here. Yes? Okay, now we are back. Now you will see that this whole big view with this collection view inside is colored in yellow, and that is because we are forcing an off-screen rendering path. In this case, this is beneficial because now this off-screen rendering buffer stays around and can be reused for every frame of the animation. And so only this one buffer needs to be blended with the background, which we can also see if we switch on color blended layers. And now we see that this whole view is tinted in red, but now it's uniformly tinted in red. So we don't have these nested boxes in each of these cards anymore, because now we have this whole buffer which is preserved and reused in every frame and blended with the background. So in this case, this change made all the difference, but it's not a general fix. So there are other cases where it will make things much worse. So it's really something you have to find out on a case-by-case basis. Okay, let's stop instruments here and see if I come back to my presentation. Good. Okay, let's move on to the next instrument, and this one is the time profiler instrument. The time profiler is all about finding the heavy parts of your code and the heavy parts of the framework code. So you can really see where is your app spending the most time. And it's also really helpful to see how well you are using the multiple CPU cores the device has available. And that's, of course, ever more important the more cores we get there. And there's potential in there. For the time profiler, it's really good to understand first how it works, because the time profiler doesn't provide a precise measurement of the time your app spends in certain routines, but it is fundamentally a statistical sampling process. And so when your app is running, then instruments comes in and takes snapshots of the current call stacks in a fixed interval, which is 1 millisecond by default, I think. And then it aggregates all this data. And that's what you see later in instruments, these aggregated call stacks. And that's important to know because, well, most of the time this is surprisingly accurate, but it's good to know how it works when you try to profile code which has a very short execution time anyway. And then you might run into the situation that you don't have enough samples to say anything meaningful what's happening there. So then it's good to know that it's not a precise measurement, but basically just statistics. The time profiler should ultimately always be used on the device and on the slowest device you want to support. But there's also, in development, you can also use it with a simulator if you're only interested in relative changes in performance. So if you make a big change in your code and you want to see how does this affect the performance, often it also gives you a good indication of what will happen. So sometimes that's just more convenient because it's faster to use. But ultimately, you should always use it on the device. Okay, let's show you another demo with a time profiler instrument. So for this one, I will open up a new session in Instruments. This time I will choose the time profiler template. And I will show you again another problem in this first version of the app, which I showed you before. So I hit record here. So now, let me switch over to my device. And now you will see that next to this scrolling to this graphics performance issue, there's another one. Namely, if I move one of these big views off screen, then there's a big lag until they come back. Do you see this? When I move it out, it stutters a lot until they come back. So recreating these big views takes a long time. And I want to know why. So I go back to Instruments and I stop it. So now we have this trace here, and the first thing I will do is I will zoom in a bit. You can hold down the Shift key and drag over the timeline to zoom in. And now you see these big blocks of work being done here. And I want to focus on only one of these blocks. Let's choose the second one, for example. And so I will set an inspection range about this region. And the easiest way to do this is to just use the Option key and drag over the timeline. Now you can see already in this little pop over there that it's taking more than a second here. So setting an inspection range like this tells Instruments to only consider all the samples which it has taken in this period of time. It's basically filtering down your data set. So if we look now to the details down here, then you see that we spent a lot of time on the main thread, which we see by the blocking. And what we can do now is we can start diving into this call stack by opening up these lines and basically following these big numbers here in terms of running time or percentage of running time. And so we can just go in here and open this up. You see a lot of code, which is of course not code you wrote or I wrote in this case. There are options here at the side to only show Objective-C code or to hide system libraries. Sometimes this is very helpful, but it's also a bit dangerous, so because you can miss things. So we can step in here further, and we will see that at a certain point we reach CA transaction commit, we go in more, and then we end up with some collection view code, layout subviews. So we could suspect at this point we might have a problem with layouting many views, but you always have to see that just because you see a call like this, layout subviews, it doesn't mean that the layouting is the problem, because if we dive in a little bit more, then you will see that UI collection view create prepared cell for item at index path is called, which goes back to your data source. So also it could be that you are doing something stupid in the data source method, and this is taking a lot of time. So you can go like this through the call stack and find out the heaviest parts, but there's also another method which I actually prefer and use more often, and that is using this extended detail view, which you can open with this button here, and it comes in from the site. And the extended detail view always shows you the heaviest stack trace for the current inspection range. And the heaviest stack trace is basically the call stack Instruments encountered the most often in this selected range. So if I go back here and we select the main thread and we focus in on this heaviest stack trace, then you will see the same path as I just showed you before. We come by this UI collection view layout subviews, and if we look further down, then we see at the bottom we have some NSIS engine calls which are related to auto layout, resolving the layout constraint system. And so we have a good indication that we are spending quite a lot of time with layout stuff. And the nice thing is that this extended detail view here and this, the call stack view next to it, they play well together. So if I select any frame here in this extended detail view, then instruments will jump to this place in the call stack. And if I select anything here in this call stack, then the extended detail view will show me the heaviest stack trace which contains the frame I have selected here. So these two really play nicely together, and it saves you work of opening up a lot of lines, but it always presents you the heaviest stack trace from what you have currently selected. Okay, I will show you a few iterations of this app, because basically this process now is just iterating over measuring, making a change, and remeasuring. So we saw now that layout seems to be taking a lot of time here. So I have another version of this app, which is this one. And I will start it. And I will do the same thing. So this time, I just stay with this screen and just do the same thing. OK. And now you can see, if we go in here, we focus in on one of these blocks, then we see that we are down to something like, I don't know, 270 milliseconds or something like this. So we already made a big improvement here. And now we can see, when we focus in on this point, then we can see that in the heavier stack trace, we now some core data code shows up. We are doing fetch requests. We are going to disk and loading data. So that's clearly not that smart in this situation. But you see now that something else showed up than before, because before we had a bigger problem than that. We got rid of the bigger problem by flattening the view hierarchy and other things like that. And now we are seeing a new problem. So let's open up another version of the app, which is this one. OK, start it. I will try to switch over here once. OK, and now you can see if I do the same thing, there's still a little stutter there, but it's getting better. Yeah. So this time, when we look at it in instruments, then you see, I hope at least, let's see. OK, now we are down to around 200 milliseconds, 215 milliseconds. So we see now we got rid of these fetch requests by prefetching the stuff in a bit smarter way. So now we don't see these fetch requests anymore here in this heavier stack trace. But now other code shows up. Yeah? So it's an iterative process you are going through here. And let me show you one last version of this app, because we still have the problem that we are not able to create this whole complex view with this collection view inside of this 16 millisecond window we basically have to not interfere with the scrolling. So what else can we do here? Let me attach it to the last version of this demo app and run it. OK, and now you will see that the next step, what we have done, is that we are laying out stuff progressively. So if I go in here, then you will see that that's a bit stuttering because instruments is running, that we lay out the stuff not all at once, but progressively. And this really helps to get rid of the stuttering here at this point. OK. And we can look at these traces once again. And now you will see, if I zoom in, that this is not a solid block of work anymore, but it's split up into many spikes, and scrolling is happening in between. So we are staggering out this work over time so that we don't interfere too much with the scrolling. OK, one other example I want to show you quickly about the time profiler instrument. I have a pre-recorded trace for this. And that is a trace of a big data import into core data. And I will just select one big block here in the beginning. And I want to show you how you can work with instruments when you're using multiple threads. Because if you have this checkbox checked here, separate by thread, then the call stack will be split up here into main thread, for example, in this case, and one background thread. And we see that the work is split more or less 50-50. And now this extended detail view with its heaviest stack trace will always show the stack trace from the currently selected thread. So if you select the main thread, then we see what's the heaviest code in there. And if you select the dispatch thread here, then we see the heaviest stack trace from this thread. So we can distinguish according to the threads, but we can also distinguish according to the CPU cores we have. And for this, we switch to the CPU strategy view, which is this tiny little button up here in the left. And when we do this, and let me make this a little bit bigger, and I will switch to CPU usage view, then we can see what's the CPU load, what's the load on each of the cores we have available, 2 in this example. And when I zoom in here, you will see a very typical pattern if you don't pay special attention to parallelizing things well, namely that you are switching forth and back, basically, between the 2 cores. There is very little work going on in parallel, but you see a lot of work done on the first core, then it switches to the second one, switches back to the first one. So we can see here that there is potential to make this whole process much faster if we can somehow parallelize this in a clever way. Okay, once back to the slides and on to the last instrument, and this is the Allocations Instrument. And this is all about memory usage. So you can find out how much memory your app actually uses and how does it respond to memory warnings. And does it abandon memory? So does your memory usage stay constant or does it grow over time? And the nice thing about the Allocations Instrument is that you can use it safely on the device and the simulator, so it's very easy to use in development also. So I will show you a last demo for this, and this time I will also use the, I will also use the simulator. So I have to switch the branch here and go to my simulator and start up this version of the app. And same process, project builds, it's deployed into the simulator. Okay, now I will choose the Allocations Instrument here. So it starts running in the simulator, and it starts recording in instruments, and here you see basically this memory trace which is recorded. And what you will do a lot with this Allocations Instrument is you want to find out if you're cleaning up things properly. So you will step repeatedly over a state transition in your app, forth and back, like this. I go in here, and I step back out. And I go back in here, and I step back out. And memory usage should stay constant, because why shouldn't it, right? We are just coming back from where we came from. So we are just always crossing the same boundary here. But we see already that memory usage doesn't stay constant in this trace at the top. So what I will do at the end is I will use the hardware menu of the simulator and simulate a memory warning, so that I'm sure that everything which can be cleaned up is cleaned up. And now I will stop instruments. And now we can look into the reason why memory is behaving the way it is. But there's one important switch here, which I should have turned on before, but I will do it now. There's in this inspector pane of the Allocations Instrument, there's the option record reference counts. And if you switch this on, we get something very convenient. And I will show you this in a second. So let me run this app once again. And I will just go over the state transition a couple of times, so that we can see well what's going on. Okay, that should be enough. I issue a memory warning and a stop. Okay, so now what we will do is we will put the timeline head here at the beginning before we started this whole process, and we will use the mark heap button here to make a heap snapshot. And then we will move the timeline head to the very end after the memory warning, and we will set another heap snapshot. And now you see here in the details, we have 2 heap snapshots, and the second one is already almost a megabyte larger than the first one. And now we can open up this heap snapshot, and it will show you all the objects which have been allocated since the baseline snapshot. And often it's a good idea to look at your classes first. So for this, I use the search bar up here, and I type in my class prefix. And now the list is filtered down, and now I see here, for example, a view controller. And if I open up this line, then I see many view controllers sticking around. So that's clearly not good. And if you check this little checkbox before, which I forgot the first time, then you get a very nice option now. If you click this right arrow button, then you get a complete history of this object. So you can see who allocated it in the first place, And then you can see all the retain and release calls which were made to this object, including their callers, and the reference count, the resulting reference count. So if I scroll down all the way to the bottom, I see that my reference count is stuck in an alternating pattern between 1 and 2. And these calls come from a timer. And now I remember that before, when we tried to make the scrolling smooth, we were staggering out the layout over time, and we used the timer for this. So probably when we reuse these view controllers, we don't clean up the timer properly, and they stick around in the run loop, and so the view controllers they reference don't get released. So this is a very convenient way to find out who is holding references to your stuff, and why doesn't this get cleaned up. You don't have to guess, you don't have to read your code like 20 times and try to find the correct spot. This is very convenient for these problems. And I can show you one pre-recorded trace, which is of a version of the app where this problem is fixed. And then you can see it should look like this, that if you step in and step out, the memory usage stays constant over time. Okay, so I hope I was able to give you, with this quick run-through, I was able to give you an idea how useful instruments can be once you get to this questions of performance issues and memory issues. And it just takes a lot of guesswork out of the equation and can make your work much more efficient there. So if you have any more questions, just find me during the break. We have a long lunch break, and thanks for your attention. And since this is the last talk before lunch, bon appetit. It's basically time over, but yeah. Half an hour.
Hi. I actually have a question in two parts. Like, I know you can send flags to instruments from code, especially send start and stop flags to measure duration.
There's also basically an API you can use, and you can in your code set these flags, so that you don't have to mess around with your mouse in the timeline to find the correct portions. I didn't have time to show this, but you can look it up. It's not very well documented, but there are examples out on the web, and you can set these flags in the code and make this easier so that it's more reproducible also if you do things multiple times. Yes.
Yeah, and then comes the second part. We had to talk about continuous integration and testing. You can launch instruments from the command line and record traces, but do you know if there's tools to extract, especially durations set by those flags, in an automated way?
I didn't get the last part. It's really hard to understand.
So you have those flags that measure durations in instruments. You can launch instruments from the command line and record traces during testing. Do you know if you can extract those information from the traces?
That is a very good question. I've never done this myself. I have read about it, but I have no first-hand experience, so I'm not really the right guy to ask there, I guess. Yeah, sorry.
Thank you.
Everybody's hungry. Okay, bon appetit.